Time for some more kitchen table astronomy with Hampshire College astronomer Dr. Salman Hameed at your Amherst kitchen table. Salman Hameed,
Amazing. What are you going to say?
you were at Solid Sound on Friday night.
Yes, and it was really cool. Watched Wilco, and they did deep cuts,
Yeah.
and those were really interesting and really wonderful. It's always great to see live music, first of all, but it's always greater to see Wilco doing live music. So no, it was just a wonderful experience. How was yours?
It was great. We broadcast it, which was a lot of fun. And if you want to relive that experience, we are streaming the Wilco set and the Jason Isbell set at nepm.org for at least a week. So you can go and relive that experience. And I know it wasn't your first Solid Sound, Salman Hameed, so I got you this pin that says "Not my first Solid Sound."
Yes, thank you so much. Oh, that's really wonderful. All right,
They gave me a fill in the blank one where I got to write eighth. Like it was my eighth. I've been to all the Solid Sounds, so that was really but I know it wasn't your first because I've been there with you before.
That is correct. No, it was a lot of fun and family event. So I went with my family as well, and the weather was perfect.
Yeah.
No mosquitoes, not too cold, not too hot, and a great drum solo.
Oh, totally. Yeah, Glenn Cochie's drum solo, something else. But we're not here to talk about Wilco. There's been too much Wilco talk on these airwaves. We're going to talk about turning on a quasar in the Milky Way.
Not in the Milky Way.
Ah.
But you know that, and we have talked many times here, that pretty much in the centers of all galaxies, of most galaxies that are big, like the Milky Way galaxy, there is a supermassive black hole. That is a black hole of the mass of tens of millions of times, and it can go as big as 1 billion times or so the mass of the sun. So you have these massive, supermassive black holes at the center.
Which kind of hold the whole thing together, right? The whole galaxy together in some ways?
Not really, because it's the dark matter that actually holds it. The black holes compared to the size of the galaxy. So, for example, for the Milky Way, there are a few 100 billion stars, so with a B, and the black hole is a few million times the mass of our sun, so our star in that context. So it's not as big compared to the rest of the galaxy.
Mm-hmm.
Nevertheless, these supermassive black holes are the ones that can produce a lot of energy. And that's how we know actually that they exist. And in fact, when material falls into them. So again, this is one of the questions that always come out, that, hey, it's a black hole, nothing can escape from it. That is correct. But if you have material around it, it usually forms an accretion disk of material. And when it falls in, before going into the black hole, this material is sped up. Because there is so much gravity nearby that the material is traveling almost close to the speed of light, and the friction that it causes. And again, so it's spiraling in, you can think about that. And the material, you can think about these particles. They are traveling extremely fast, and they are rubbing against each other as well, and that is producing heat, energy, and that is oftentimes what we see around it. And in fact, if you want the most efficient way of creating energy, some might say, hey, nuclear fusion, right? Where you take 4 hydrogen atoms, fuse them into helium. This is called hydrogen fusion. And a little bit of mass that is left over, E equals mc squared, the Einstein's equation. Well, that's a lot of mass that you can create. And so right now we think that hydrogen fusion is the most efficient way.
Actually, a lot of energy you create.
To create energy. How much mass you take and how much energy out of it would be. Actually, it's not. It actually is 7% efficient with the hydrogen fusion, meaning to say only that sort of that's the mass out of it that you're creating energy of. Supermassive black holes, accretion disk around that, the efficiency is around 50%.
Mm-hmm.
Except that in order to use that, you need to create a supermassive black hole, and you need to figure out a way to harness that energy.
Yeah.
My point is that these are amazingly strange objects, but they produce energy not from inside the black hole, but from the material that is around it. Now, Milky Way black hole is actually what we would call quiescent. It's actually not very active. meaning to say not much material is falling into it. When a lot of material is falling into it, we call those active galactic nuclei, because these are in the nucleus of galaxy. And they are active, and they are in the centers of galaxies, and hence the name AGN, or active galactic nuclei. Now, as I mentioned, something like the Milky Way, the supermassive black hole at the center is not very active. And then there are other galaxies, and you can go up to extremely active galaxies. Some are called quasars, where they are so bright that they outshine the entire galaxy. You only see the center. And so those are strange things, because the center is so active that it is outshining the brightness of a few 100 billion stars. Now, what astronomers have recently found, so this is a galaxy, again, name doesn't matter, but if you are a name nerd, it would be SDSS 1335 plus 0728. Basically,
Creative.
This is Sloan Digital Sky Survey, and rest of it are the coordinates in the sky. So this is a pretty unremarkable galaxy, and it was observed in 2019 to see that the center suddenly got really bright. And occasionally astronomers have found these type of events happening. For example, they call it if the supermassive black hole swallows up a star, or some bigger chunk, a cloud that it swallows up, suddenly you see a brightness that comes to it. Except that you expect when swallowing up a star, it's called tidal disruption event, because the black hole basically disrupts that star, tidally rips it apart, and then the material, as it spins around the disk, it gets heated up, and that's what you see. But in those cases, the brightness goes down after a few days, few weeks, or at the maximum a few 100 days. But in this particular case, it has been 4 years, and it is still bright. And in fact, the way it has brightened up, and in the wavelengths it is shining really bright compared to before, that suggests that somehow the center of this galaxy, the supermassive black hole, was inactive, was not active, and now it has been switched on.
So we've watched this galaxy turn on its quasar in the middle of it?
Yeah, so I wouldn't call it quasar, because that's a a really big version of it. But yeah, you can think about it as that its nucleus has become active, its supermassive black hole has become active, or this galaxy is now what we would characterize as an active galactic nuclei, an AGN.
So astronomers have seen these AGNs, these active galactic nuclei, observed in the universe, but they had already been on. This is the first time we've seen one that was not on, that's now on.
Right. I mean, just think about it. You have these things happening on the scales of hundreds of thousands or billions of years in general. That you have astronomers watch these galaxies. But here we have seen a galaxy switching on the nucleus, or whatever happened. And actually, it's unclear exactly what happened, because you have oftentimes material around it, like the center, or near our black hole as well, but the material has to start falling into it in a large quantity, that then it stays there. It's constant stream of that material. So you have seen the image of the accretion disk of the supermassive black hole, the one around the big image that had come up with
a couple of years ago. UMass Amherst astronomers were a big part of imaging this first ever black hole.
And that was the shadow of the black hole. So that was the event horizon.
Yeah, astronomers get mad if you say, I saw a picture of the black hole. You didn't. You can't see a picture of a black hole. You saw the accretion disk around the black hole.
And in this particular case, it was also the shadow, because you could see light missing from it. That's what we were seeing. So even further in to just from the accretion disk. And so that is a case where the central component of the black hole in that particular image was actually active. Now, they also have an image in that sense of the shadow of the Milky Way, the supermassive black hole at the center of the Milky Way. But it's a relatively quieter place. In this case, the one that astronomers imaged in 2019, and they have been constantly observing it, they found that it went from being relatively quiet to being active. What happened? We don't know. That's what people are trying to figure out. What triggered this thing? What triggered the material from the accretion disk to constantly stream into the black hole compared to before?
I think that the fact that it's trash day in Amherst is a microcosm for what's happening. So as it was quiet while we were sitting at your Amherst kitchen table, all of a sudden the trash truck has come to pick up the recycling. The trash truck is like the supermassive black hole, picking up all this material and dumping it into itself, and now all of a sudden we can see it. And there it goes down the street.
I wish it was a black hole that we could put in the trash. Unfortunately, that goes in somewhere, and then it still is part of the problem of our crisis on our planet. So I wish there was a black hole that you could just dump all of our trash and we would never see it again. Unfortunately, that is not the case. But yes, in some sense, at least we have a trash.
I think that's true. And it is amazing that scientists have seen this turn on, when they have observed it in the past, could have been burning for thousands and millions, if not billions of years that they've seen before.
And it's also possible that it may have been active before. And then it went quiet, and now it is active again. So this is a really interesting case where astronomers can actually monitor that, and it tells us about something potentially what is happening at the center of our own galaxy. People expect, hey, maybe our black hole is going to start sort of like, doing some interesting stuff as well, but we don't know.
Tying it back into Wilco, it was at one point a bull black nova. And now it's a hot sun with a cool shroud from the new EP.
The new EP is great, and I am sad they did not play a single song from it, at least on Friday. Did they play it on Saturday?
I think they played one on Saturday, yeah.
And I'm livid because of that.